Welcome to another installment of Two Healthcare Guys, or at the moment, one healthcare guy, talking with Shamit. Shamit, thank you so much for joining. Hopefully, we'll be us soon. But for those that are just joining, can you tell them a little bit about yourself, your background, and Nova?
Sure, absolutely. Well, thanks for inviting me, first of all. And I'm really excited to be here. And just a little bit about myself. I come from wireless semiconductor background. I'm a serial entrepreneur, helped start a lot of startups in my days, and with successful acquisition from Fortune 500 companies like Intel and Qualcomm. And if you're all wondering what am I doing in healthcare, that's a question that I get asked a lot. So I'm in healthcare because we've always been in that situation where we're in pain, or worse yet, in a desperate need to know what's wrong with you and the diagnosis that you want to get an answer to, and then wait for a doctor's appointment for 3 weeks before they'll give you the first available slot. Well, I was in that kind of situation once, and I didn't like that feeling, and that motivated me enough to leave my day job at Intel and start this company to help automate and accelerate every single patient journey to get them to care as quickly as possible. And that's a little bit about myself.
Well, serial entrepreneur, as a burgeoning entrepreneur myself, I might be reaching out because I need a lot of advice.
I have a lot of failures that I would love to share about, and that's what makes me who I am today. It's not the success; it's the failures.
Well,
so I'll be happy to talk about those. They're more fun. In fact,
my list of failures is growing day by day. So
that's good. See, one particular failure that I'm very proud of is I was responsible for launching a product that was rated as the worst product of the decade by Engadget, and I have my name on it. So I'm very proud of that.
Right?
In fact, if I ever make a resume, that would be the first thing that would put on
It's like the actors that have the Razzie Award, and that's the only one that they have up on their mantle.
there. Yeah, and that's the piece that I'm more proud of my failures more than anything else, and I've learned something new every single time.
I mean, I think that's what defines us. That's what grows us. That's how we learn. And it's the successful person is the one that got past that one last failure. I think in Think and Grow Rich, one of the examples, success is six feet after the last guy quit, and it was actually a story to a gold mining. A guy lost $2 million, dollars back in the 30s, I think it was $2 million on a gold mine, and sold it. The next guy just walked in, drilled 6 feet, boom, struck.
I've seen that picture, and I always remind me every time I see that, I always remember that. And my father always used to tell me, never give up. And I kind of see it from that picture that, the success might be just 6 feet in front of you.
Yeah. I mean, that's that specific story. The 6 feet is actually a true story about a gold mine. But
I did not know that.
Yeah,
Wow.
man, I wish I could totally reference it. But so we actually met on LinkedIn, and you not only you're a little humble there. Not only are you a serial entrepreneur, but you've started an AI company in healthcare. And what I find really fascinating about your AI company is something that I truly believe in, is that AI is not all about image interpretation and pattern analysis. It's about solving real world problems and automating things that don't necessarily need a human to make a conscious decision on. And so, for those, if you could just give a quick overview for people to understand what I already know a little bit about your product and what it does.
Sure. So I always like to start off with a problem, and what is the problem that we're trying to solve, right? And it came to me while I was waiting at a doctor's office after 3 weeks of waiting to get to the office itself. And I had my phone on me, which allowed me to start looking at how much money is getting spent in healthcare in the United States. At that time, it was about $3.2 trillion with a T.
Okay.
And I'm an Indian. I come from an Indian origin, and at that time, the GDP of the country of India, a country with 1.2 billion people, was about 2.2 trillion. And then that hit me that we spend in the United States more money on healthcare than every man, woman, child, company, government, everyone combined together in a country of India.
Wow.
Why are we waiting so long for our doctor's appointment? And I had no idea. And that is the birth of this whole company. And what we soon realized after looking at more and more data that about 20% of all expenditure that we have in outpatient care is before the patient even gets to the exam room in payroll alone.
Wait, how much? Right? How much is before?
20%.
Okay.
Before the patient even gets to the exam room. This is in scheduling appointments, dealing with insurance, registration, front desk, everything else. We're just talking about payroll expense. I'm not even getting into the rent and utilities and everything else that goes. This is before the patient even gets to the exam room, right? And then I realized that this is an industry. Well, which healthcare provider wants to spend more money on administration? They would rather spend that resources on patient care, right? That's one big challenge right there. And then comes the next piece, which there's a big story about this, and that I painstakingly found after having a completely different picture of how this industry would run. Coming from a semiconductor background, I expected this industry to be at like 90-95% utilization, and we're trying to come in to make that last 5% improvement, because that's what the value is. Oh my God, I was so wrong. And I kind of give this credit to our CTO, Dr. Piyush Goyal, who asked me a simple question: have you spent time in that clinic to see what's going on? And I was like, no, I looked at the sensor data, and that's what the data is showing. Well, why don't we go and see? And that's when we went in. And what we realized that more than 30% of clinical capacity gets wasted every day. Right. This is huge, right? While patients like me wait 4 days for their appointment. So that's essentially the problem, and that's a $500 billion problem in outpatient care alone. And we started saying is, how can we help utilize all available capacity that's in healthcare by automating, giving that agility that the healthcare industry needs to react to no-shows, cancellations.
But aren't these people problems? Like, isn't this just bodies not in the right place? How is AI going to fix, butts in chairs?
So that's another great question. So one piece is, let's look at the actual problem that I see, 30% unused capacity. Let's break it down to what causes that. So the root cause, number one, is capability, right? And when I say capability, I mean, to solve that problem, you almost need this superhuman capability to be able to know and identify which patient is not going to show up, or which patient is going to show up late, right? Or which one's going to take longer to do the registration. I mean, given enough data, you could probably figure it out. But by then, when you identify that, hey, this is a serial no-shower, and to react to it is the second problem, is the agility and human resources to be able to react to this problem, right? That's the second problem. Now, the reason why that's a problem is because what we found out in diagnostic imaging, that more than 90% of all appointments are booked by a call center, even if they have an online scheduling system. More than 90%. And that's why
that doesn't make any sense. Why would someone go to a call center if you can book online?
Well, because the demographics, the median age of patients looking for diagnostic imaging services is about 66. Right? Now, that is an age group that would pick up their phones first to make a phone call rather than searching to see if there's an online scheduling service available. Right? And furthermore, it's not like it's a consolidated industry where you can go to Expedia and actually get appointments for every single imaging provider that's out there. It doesn't exist. In fact, that's where our CTO comes from. And can I
of course.
Take care of I apologize. My dog just went a little loose, and that's what happens working from home.
I just said the same thing.
Oh, is it? All right. So going back to what I was saying is, it's a demographic that picks up the phone to make a phone call. not to search, right? And furthermore, our CTO actually comes from Expedia. So we actually have a lot of experience understanding how airline industry works and how booking works. And with diagnostic imaging or healthcare in general is such a fragmented industry that how many places are you going to go and check if they have online scheduling, right? It's just, there's a layers and layers of complexity that demographics that use those services are just not used to, right? It's easier for them to pick up the phone. And there's another last piece of complexity to deal with it. And that last piece of complexity is, even I had a challenge with it. I didn't know what mammogram was till after I jumped into this industry, or what an MRI machine was, or what the CT machine was. I learned that the hard way. And I wouldn't expect my parents to know what that is off the back, right? We take that for granted being in the industry now. And that was one of the biggest challenges, is to go find out. So because of that, more than 90% of those appointments get booked by call centers, right? And on average, we did our study to find out that more than $7 for every exam completed is actually spent in scheduling appointments and payroll.
Okay.
Right? Now, if that's the case, then imagine if all of these payroll expenses is actually going in spending and actually booking appointments, the agility that's required to react to a late arriving patient or canceled appointment, to be able to call a whole set of new group of patients to take that last minute slot is almost impossible. Right? Because how many patients do you have to call? First of all, you have to constantly monitor which ones are canceled, where are the open slots, and which ones are not going to show up. So this is where AI can really shine. Right? AI can really shine in problems like this, where it's not something that you're trying to solve that's unique. It's something you can solve given enough time, but you have to do it fast enough to plug that hole. And that's where AI shines, right? A really good example I like to say is like, calculator. It's not like we can't multiply two big numbers, right? But calculators can do it much faster. Given enough time, we can do it as well. But calculator can do it faster. And AI is one of the views of looking at AI is in that particular paradigm.
So one of the things I'm fascinated and befuddled by is how AI learns. And so, how is AI going to know that, Wayne is going to be a no-show? Not to pick on Wayne, but he didn't show. So how would AI have predicted that? Like, isn't that, how does AI know that someone's car isn't going to start that day, or they got stuck on another Zoom call?
That's a really good question. So there are two pieces in there. One is, how does AI learn, and how does an AI solve that problem, right? So let's kind of break it down into two.
Okay.
And the example, there are three components to that. How does an AI learn, and what is it that we need to teach it? It kind of breaks down into three simple pieces. The first is that AI and AI needs to work together. Actual intelligence and artificial intelligence are kind of two pieces of it where they have to work together.
Did you just say I and AI?
No, AI and AI. Actual intelligence and artificial intelligence, right? So the very first thing that you have to do is figure out what game you're playing. AI is nothing but a simulation, and it's the game that you're trying to play, where you're trying to improve a score somewhere, right? Without dying. And like, think of that as a very, very simple way of thinking about this, right? So let's take a Tetris as an example. Okay, it's a very simple game. You're trying to fill as many gaps, as many rows as possible. You have these random blocks that are coming in, and your job is to fill as many rows as possible without having that block tower go and hit the top, which is where you die, right? And the end of game, right? And the longer you pay, the score kind of goes up. So that's the first thing. You have to know what game you're playing. Second thing is, you have to know what are the inputs and outputs. Right? So your input is, you can either go left, right, down, or rotate the block clockwise or anti-clockwise. Right? These are 5 outputs that you have. That's what you're trying to change to be able to go and fill the rows as much as possible. Right? So that's the second big element. If you know what your output is, The actual intelligence goes in trying to figure out what are the key deterministic inputs that you need to send to this block of magic that gives you those outputs that you're looking for, those 5 outputs, keystrokes that you're looking for, right? That's where a lot of actual intelligence goes in. And in our technical term, it's called feature hacking. It's figuring out which features do you pass into the models, what inputs do you give it to be able to go and determine for that model to go up and down, right?
So I got a quick question. How does that,
please.
So in statistics, I mean, I do regression analysis to determine like which variable is valuable, which, you know, then I can say, well, this one is significant and I throw it out, or not significant. I mean, do you do that same thing, or do you have to know that ahead of time to send it the right features?
Combination.
Okay.
It's a huge portion, combinations of doing regression analysis manually, as well as throwing a whole bunch of data at type of machine learning models that you're trying to build. So if you're trying to do deep neural net models where you're just throwing a whole bunch of data at the model and giving the truth, the real data, which is the last piece,
right?
And the models start building from itself.
Okay.
Using the data, right? So in that example that I gave you for Tetris, right? The model is looking at each block that's coming in. So that's the information that it needs. So you have to somehow represent that into an input. The type of block that's coming down. You have to represent what does that picture look for the Tetris blocks that are in there already, right? What are the empty slots where it can actually go in and fit in there? That's the feature hacking piece. That's where actual intelligence goes figuring out what are the inputs that you need to send to the model, right? Once you have the input and the output, you just, last piece is throw as much true data, clean data as possible. And the model gets built on its own. The system will automatically put, you know, all those keystrokes to get the results that you want. Now, that's how you build an AI to play Tetris. So going back to the first point I made, if you're trying to build a model to take over any kind of work, first you have to know what type of game you're playing. Game of scheduling is nothing but a game of Tetris. You have blocks, you have empty slots. It's just a slightly modified version of Tetris. Instead of when every line is full, at a particular predetermined time, the blocks keep going down. And the game that you're trying to score is not how many lines you completed, but how many full lines you completed in that amount of time. Right? So that's the score that you want to improve on. AI is very, very good at learning how to improve the score that you want to improve with the deterministic input and the outputs that you can control that score. So if you can change the problem that you're trying to solve into a different problem, determine what the inputs and outputs are, then you can actually teach AI to solve that particular problem, just like a calculator, to do that one specific thing really well.
So what, I mean, I'm sure it's fairly complex, but can you give me just a few of what are the things, if we take the problem of how do I know who's going to no-show? Just let's focus on that problem. What are the kinds of things that the data that you would have to predict that?
Okay, so let's try a slightly different example.
Please.
Let's say a late arriving patient, right? So when a patient comes in late, that capacity is wasted and that will never come back, right? Because if an appointment's scheduled for 9 and a patient comes in at 9:30, that time is lost, right? Can you imagine the impact weather and traffic would have on the arrival times of the patients?
I can imagine.
Right? So we spend almost 2 years in analyzing 2 million exams for our partners to start figuring out what are the cause and effect, what causes, what are the correlationship between these external factors that we're seeing and the impact it has on arrival times of the patient, no-shows, cancellations. They're internal as well as external factors that affect it. So as I was mentioning, the key in determining the AI is figuring out the deterministic inputs that you can send to the model. This becomes that deterministic input. So our model that we've built that takes a look at these external factors as well as internal factors: age, income level, education. These all impact what would a patient do in a typical setting. And the output of the model is, think of it as a heat map that says probability of when would that particular clinic have capacity to see one more patient successfully. And successfully means without increasing the wait time and without having the tech work overtime.
So in terms of, so back to the late arrivals, you basically spent 2 years combing through data, sitting in imaging centers, trying to figure out, how many people don't show, and ask, do you talk to text, and the process improvement on the internal side, and then just grabbing data from externally and say, gee, it's snowing outside, and I noticed today that 10 people didn't show. Wait, I need to go now capture weather? Is that?
It was more elaborate than that. So our CTO has over 15 years in experience building similar models for the airline industry.
Okay.
And we've leveraged a lot of the learnings that the other industries have in this space.
Oh, we don't do that in healthcare. That's not allowed. We have to build from scratch.
Well, I mean, we tried that, and I tried that, and I failed miserably. There's another big story about that. But we leverage a lot of lessons learned in other industries where operational excellence that they have is impeccable, right? And airlines, one of those industries. As much as we like to complain about airlines, if airline was running like healthcare, I wouldn't be traveling. Right. That's kind of where things come from. And we leverage all the lessons learned over there, information that's available, and our home group analysis from 5 different data scientists that we had planted in Tampa, Florida, at one of our customer sites, learning about everything that we did from data. Right? Along with each one of us has spent almost a year doing every single job function from front desk to scheduler. And we had a very good partner that allowed us and gave us that opportunity to be able to do that. And that's time that we spend allow us to understand what are the back office challenges these imaging centers face, right? What are the kind of things that they run into on a day-to-day basis? And we started saying, where can we get data to go and start finding correlation?
So let me stop you. You actually had your staff, like full-on data scientists, like genius people, sitting at the front desk and registering patients and like doing the jobs in an.
Absolutely.
Okay.
Absolutely. We actually had them do in the way that we view things is very simple, right? If you look at a definition of a data scientist, it's someone, first, you have to have math skills. You need to know mathematics, probability, statistics, and so forth and so on. Second skill that a data scientist would have is being able to program, right? Doesn't have to be the best programmer, but you have to be able to do Python and few coding to be able to do it. But if you just have a data scientist who has mathematical capabilities and programming capabilities, that's a very dangerous data scientist. It's not going to produce results that you're looking for. There's a third very important aspect of this, and that is having the domain knowledge.
Right.
Because a data scientist that doesn't have domain knowledge is dangerous. It will put you through rat holes that you don't want to go in, and it will take you a long time to crawl out of that, right? So, and there aren't any data scientists that have that domain knowledge expertise that's required in radiology or in healthcare and outpatient settings and operational side, right? So one of the things that we were very proud of in the company that we've created here is we've got a multidisciplinary team of operations researchers, mathematicians, and engineers working together to learn about this domain expertise that doesn't exist outside.
Uh-oh.
Hello,
hey, you're back.
Sorry to keep you hanging. This has got to be one of the most interesting podcasts.
It's all good.
Just had a short power surge and the router went off.
It happens. Well, we were just talking about domain knowledge, and it actually kind of reminds me of an early study I read that was talking about AI learning, and of course, correlation does not equal causation. Words to live by. I should have it on a coffee mug. But
Yes.
interestingly enough, it pointed out that the consumption of margarine in Great Britain perfectly correlated to divorce rates. Like within
Yeah.
very small percentage of sampling of error. And
Right.
so, I think that just explains that while the data may match through random chance, but with no domain knowledge, you'd go, huh, isn't well, there you go. You needed to eat less margarine. But your point of having that domain knowledge, not only to know that that's irrelevant, but also know where to go look. As soon as you said weather, I go, duh. But it never would have
Yeah.
occurred to me. And then, but I mean, that's a massive
Correct.
amount of data to comb through.
Correct. No, I mean that's exactly right. And there's another element to this
Hmm.
as well. All right. Uh, as you mentioned, correlation does not always equal
Hmm.
causation, right? The beauty about AI and the machine learning tools that exist, um, the output that you get are these probabilistic
Okay.
model, right? It's not going to say that this is the person that's
Right.
not going to show up. It's going to say, hey, this is where you will have capacity from this time to this time to see one more patient without increasing the
Hmm.
wait time or without having a tech work overtime, right? Now, those probabilities are something that allows us to get a
Okay.
dial to be able to tweak, right? And that's where we have something called back proposition or
Okay.
reinforcement learning, right? And allows us to improve the assumptions that the model
Hmm.
is making and how to tweak the right weights and balances at the right
Okay.
places to improve the performance of the model. So to give you an example, a positive and a negative reinforcement works in a way where if we predict that there's going to be a capacity here, we have the real
Right.
data, right? At the end of the day, we'll know what
Hmm.
happened, right? And if our models are wrong, we will actually go back and tweak the parameters that are needed to go back and say, oh, these things are not matching up. We need to fix that and re-improve it and see if we can get better
Okay.
results. And it gets better and better over time as we get more and more
Hmm.
data, right? So the key here at the end of the day, as I mentioned, first is to know what game you're
Right.
playing, right? Second is figuring out what are your inputs and outputs. And third, most important part is clean
Okay.
data, more and more clean data, right? If you have those three components, that's when you can actually start to think about building an AI system or machine learning system to be able to solve a problem, right? You have to have those three very critical
So
pieces.
I remember another. I mean, I try to read on AI. It's so important to the industry and will be to most industries soon. I remember reading about oversampling and having. To me, that means too much data. But you're telling me you have to have lots of data. Can you help me understand the difference between what is oversampling and how? Simple words
So
for
let's
us.
okay. A simple words would be if I only had data from sunny Florida,
Okay.
right? Where everything is exactly hunky dory and there's no, that just one type
Hmm.
of data over and over and over again. The machine's not really going to find the correlation between what's the impact of what different types of weather and what impact it would make on the
Okay.
results, right? So when it comes to data, lots and lots of data doesn't mean that lots and lots of same type of data, but a variety
Okay.
of data, right? And I think I'm sure you've probably seen a lot of um, big chatter on the internet about AI where color of the skin makes a big difference because the samples that they use of the
Hmm.
same
Right.
color, which kind of skews the results a little when you actually start putting a different
Right.
color tone, right? So when it comes to oversampling of the same type, you need a lot of variety of data to be able to make really good decisions and outcomes that you really
So
want.
you're saying oversampling means I'm using the same or a very similar set of data, lots, and
Correct.
you're telling me it's more about getting a variety of data?
Variety of data. That helps go and start finding more features and what their influence on the outcome there is for those type of
Okay.
features.
And so some more basic questions, sorry. What is the difference between machine learning, cognitive computing, and artificial intelligence? Are those just terms, or is there meaningful difference between these things?
Huge difference, right? So if you think about it, artificial intelligence is this like big, broad
Okay.
spectrum, right? Um, Technically, you can also call this an artificial intelligence system. right? It's an algorithm that's running, that's computing, solving a problem. Machine learning is a term where a machine, instead of humans building algorithms to do certain things, right, get an input and get an output out of it, it's a system that learns how to create those models on their own.
So that's that reinforcement, the positive and negative reinforcement that you talked about?
Reinforcement, learning from the data, trying to improve and build upon those models. That's what machine learning is. So one is the process of creating those models to do the work on its own without any human interaction. And the other piece is artificial intelligence, which just encapsulates that entire process, right? It's the process of learning, right? That's machine learning.
Okay, and then cognitive computing, is that what does that mean?
You know, I depends on the context that you want to use that in, right? Cognitive computing is trying to take a model and running it on a hardware or a device where you're actually taking the input and getting the output for it. Where the models run, that's what you would call cognitive computing.
Got it. That helps a lot, actually, of putting it into context. Okay. And so in a lot of AIs that we see on the market, you buy this thing and you get it. And so how do you, so you talked about the training where you, presumably your staff is there, you get something, you then look at the data the next day. Now, is that something that you do manually and to a point where you say, okay, this is now thus be trained? Or is that baked into the application?
So that's a very, very good question. And I think it would differ based on the application that you're trying to build and what your objectives are and the business models are, right? And business models around that would dictate what your internal processes are to keep improving the models, right? I can talk about the way that we particularly function and what we do. So our job is very simple. Fill every last empty slot that we can before it goes to waste. That's simple as that, right? And help as many people as we can, as many patients as we can. Our rules are fill those slots without increasing wait time and without increasing tech overtime, right? Those are the two parameters. That's the game that we play every day. Okay? And in that game, we have our internal KPI metrics that we track every day to see, are we following under those metrics and the band of error that we want to be in. And every time it crosses that band, fire alarms go off. We start figuring out, what did we do wrong? What are we doing that's not working out? We can constantly and every day run new experiments on our system because it allows us to do it. All it is a parameter change in a system somewhere that allows us to see what would happen, right? So we ran several such parameters changes and system tweaks for our partners to see what would happen if we do this, right? And what would be the effect on the other side. I actually have a really good example of how something kind of went out of whack. And that's how we learned what the impact of the tech is. And there's a really funny and a really interesting story that actually starts off that just comes to mind. And this was probably January of 2019 is when we discovered this. So we had our models built, for one of our partners in their mammography service lane for one of the centers, right? That's where we started off to kind of start figuring out what causes wait times to go up and the techs to work overtime and capacity to go wasted. And we were predicting wait times for the patient, because that's one of the metrics that we always look at it. Because if I can predict wait time, then there's a very good chance I can actually predict when there will be capacity, right? Because if low wait time means there's no one there, there's an empty slot, right? So if we can predict that properly, then we can actually predict capacity in a very, very accurate way and with very high level of precision. So we started off with that, and we're monitoring that. What's our predicted value and what's the real value, right? Like you have two lines, what's the reality and what's we're predicting. And the difference between that, you'll always see difference. You don't want it to go like out of whack, right? So we looked at it at the micro level on day-to-day basis. Everything's fine, everything's good. But over time, we started looking at January versus February versus March, and we were deviating a lot from what the predicted value were versus what the reality was. So we were just baffled and said, what just happened? We didn't tweak anything. We didn't
Right.
change anything. It's the same thing. Why are we getting so far off from the norm, from the actual values? Why are the error rates so high? And someone actually had the insights to go in and let's see what the techs are doing. Like, what's the difference? What did they change a process? Turns out that our partner had a tech who was asking for a $2 an hour increment in raise, and she didn't get it, so she decided to leave. And they replaced that with another tech. It was one of their floating techs that they had. They replaced it with that. And that tech was by far not even close to as efficient as the tech that they lost, which impacted massively on the wait time. So one of the things you asked us about, how do we go and predict what would happen? Well, productivity of tech is definitely one of them, right? And that's how we learn about this. So there are these key metrics that we actually find out. We further went in and did more analysis to see, was it worth it to give that person an extra $2 an hour and bump? And mathematically, we created a model and said that particular tech was making that customer additional $15 an hour because of how productive they were and how much more they could have done. And that $2 an hour would have been a no-brainer to give. That was one of the fastest tech that they had in their organization, right? So that allowed us to see that, hey, tech productivity is a huge portion of this. So now when something like staffing change occurs, that becomes one of new features that goes into the model that looks at this and say, oh, this is how we can actually get it better. Whenever we have some unknowns or uncertain, we can go and tone down the models a little bit more to say, this is how they will behave. As we get more data, it'll get better, right? So it's always this trial and error, and we constantly work towards improving our models to get better and better at predicting.
So you have real-time feeds from traffic, you have real-time feeds from weather. Now you're adding in a scheduling staffing to know which humans are around. And all of that goes into this real-time decision to go, oh, guess what? You're about to have a 30-minute opening.
Correct. There's actually one more component to this that kind of goes over. In fact, that was my creation, which I'm very proud of too. We have a tiny sensor that actually looks like
there it is. Okay.
Looks like this, right? It plugs into the wall socket of every single exam room and allows us to know exactly what percentage or what portion of the capacity that's available in that exam room that's actually getting used. How long is the room empty for? How long is a patient there alone? How long is a tech there with the patient, right? All of that information with an internet-connected sensor gets that information to us in real time. The model, think of this sensor, what it allows us to do is real-time time and motion studies, right? In healthcare, there are always these healthcare consultants that the healthcare industry hires to do time and motion studies to say that, hey, this is how you should schedule your appointment. But that's what they're trying to do. They're trying to figure out what is the reality, what really happens. But they do it once or twice or for a week. That doesn't represent what really happens. Their sample set's so small. Think of that happening in real time. And like the example I said, like calculator, if you give me a 20-digit number, I can give you what the multiplication of those two numbers is going to be. It's going to take me a long time. Calculator is going to be able to do that faster for me, right? So Six Sigma consultants, these operational excellence folks, I mean, they're really good. They know what they're doing.
You're hurting me now because I was a consultant for a long time. So this is...
Oh, no. I love it. Look, they know what they're doing, right? They're doing the right thing. That's what they're trying to do. They're trying to figure out what the output is, and the input is the schedule. What they're trying to do is give you recommendations of what you should tweak your schedule to improve the output. The output is to be able to maximize what you can get over here. They know what their input and outputs are, right? Given enough time and given all the data sources that we have at our disposal, they can do a better job, right? Like they can do a better job at predicting these things. All we've done is taken what's in their brains and the process that they know of, automated that, so we can actually do that faster. We've just built a calculator to predict capacity to do it quick.
I mean, what's funny is you're sitting here talking and my brain is just firing away. This is Taylorism. This is scientific management.
That's pretty much it. AI is nothing but that. It's if a human can do it, that's where it's actually learning all these things from, right? Machine learning is just the same exact thing. If you can teach a human how to do a certain thing, you can teach machine to do the same exact thing.
And I love that your face lit up, because I don't know that how many people are going to know who Taylor is and what scientific management is, but you know, I'd write couple papers about that, so it's burned in.
No, I mean that's literally what it is. It's as simple as that.
That's especially with the motion study. That's what really triggered me, was the motion studies. Yeah.
Rapid motion.
Like,
Yes. That's this is exactly that. It's a think of it as one of those lean Six Sigma consultants,
right.
automated in real time with artificial intelligence, equipped with more data sources than they would have access to, continuously across the whole enterprise in every single imaging center. And
You mean
every
a
single
Six
resource.
Sigma consultant standing behind in every room behind every person with a clipboard, all watching, and somehow
Exactly.
Borg connected to
Exactly.
each other to put it all together.
And connected with an automated
Right.
scheduler to fix that schedule in real time, right? That's what it, the way that I describe our services to our customers is, think of this as like the greatest Tetris player that's out there that plays Tetris with your
Right.
schedule in real time, right? It's just trying to fill up as many lines as possible.
So before we run out of time, there's something that, you know, and I don't know if you, what, since I happen to have known, because I've seen your product that one time, and what I found absolutely startling, amazing, baffling, you know, game changing, is we've been talking about scheduling, but you actually built it so that it can run without an interface, and it was like, it's like the ghost mouse. Like, you showed me a mouse, the AI moving a mouse around on, you know, pick your EMR vendor name. I don't want to throw in, you know, Epic Cerner, Wristlink, who know, you know, Meditech, Allscripts, whatever, whichever one it is, but actually moving on their software without any fancy interfaces and taking the calls and auto voice recognition. It's actually doing all of this. And so, you know, if you could just clue people in a little bit about what that actually does and how it's working, because I think I think we get the idea of what's, you know, how important scheduling is, but then the last piece is putting it together into operations.
Yeah, and that's what took us the most time, right? So it all came out of necessity, right? I mean, this is what happens when you put a semiconductor guy and an airline guy in a healthcare, and then we start figuring out how to automate things as quickly as possible, right? With whatever is available at our disposal. And you know, healthcare is tough. I learned a lot of things being spending some time in this industry, and the pain that everyone goes
Right.
through every day. Interoperability being one of the biggest ones, right? At first, when I was reading about these things before I even thought that I'm going to start a company in healthcare, I always heard about, I'm like, interoperability. What's a big deal? I mean, I helped start a standard for Internet of Things, and I know the challenge that we faced in interoperability
Right.
for Internet of Things, right? But health, I mean, it's software. Connect them together. We're like, what's the big deal over here? And then I learned through a lot of my failures that it's not as simple as you think it is. And I understood exactly what people meant when they said this, right? And huge portion of that comes from that I believe it's as a result of manual human-driven processes, right? And the second big component of that is the tools that are given to this industry, that are available to this industry, that are not equipped for the things that it should be doing in this day and age, in the century that we live in, right? So those are the two big fundamental problems that we faced. And you know, we built a system that we're pulling data out was easy, but putting something in, well, forget about it, right? You can't do that, and that would require massive upgrades of the software and this, because they didn't design it in that way, right? It was designed to use it in one way and one way only. And every time you want to make a change, it's very expensive, which no one wants to cough up without knowing what's the ROI. And we kind of understood that if we were to show a massive improvement in performance in running the operations, I'm just not going to be able to do it with human beings. It's just not going to be possible. Agility is a very important aspect, right? That's one of the main reasons why capacity actually goes to waste, because the reaction speed that's required to solve the problem is not there. One piece is capability, which our AI brings in, but the second piece is agility. That if I can identify a slot, but I can't fill it, that slot is practically useless to anyone, right? So we kind of knew that we have to do some innovation over there. And today, when we first built the capability to do prediction, we gave it to our partners and said, hey, here you go. We're super excited. Now you have something you can do. And they tried solving the problem the same way the industry knows how. You pick up the phone, call patients, and you have to call like 50 people before 5 of them will pick up, and it just doesn't work that well. So we said, okay, what can we do to speed up? What can we do to improve the agility? And computers can make phone calls really fast. I mean, you're making a very simple use case here, just offering them like 4 or 5 slots for them to pick up one. There are technologies out there that does natural language processing that can speak, that can actually do that conversation. And we're not trying to make it super complex, keeping in mind that the demographic that we're trying to cater to is 66, right? Like median age. So we started with simple solutions and try to get and measure the results that we can get. And we were super excited with what we were able to pull off with automation. We didn't expect it to work that well, but the results and the demographics that we were actually even situated in, we were expecting this as another colossal failure. We wanted to see how fast we can fail on this, so we did it really quickly. And we were surprised at what we were able to do. So we said, okay, we need to do more. Then came time we had humans go and make the manual changes in the EMRs and said, well, that's not cool. I mean, we're spending so much time doing this thing over and over again. And then we looked at it, and our partners have like teams of 60, 70 people who are doing this job every day. And we said, oh my God, there's something bigger than what we've solved that needs to get solved, right? And you can't have these kind of folks doing the same thing over and over again. And then we kind of started thinking from a very simplistic view. If I have to schedule an appointment, I just need like 3 or 4 pieces of information, right? As a scheduler, I need to know what your name is, right? What type of appointment you're here for, date and time. That's it, right? And then I, as a scheduler, having done that job, figured out it's simple as a specific mouse clicks and keystrokes that I have to do to be able to put that information in the system, right? So if I'm just doing that same thing over and over and over again, why can't we simplify this with robotic process automation? So that's what we essentially went ahead and said, instead of waiting for years to get the right interfaces that we need to get this off the ground to show the value to our customers, we like working in speed, right? Like, I wish there was the equivalent of Moore's Law in healthcare, because the Moore's Law dictates that computing power is going to double every 18 months. It's going to take 18 months just to get an interface, right? I mean, you're not even going to get something started in that time frame. So that's why we started venturing.
So what kind of result did you see in your first customer, or do you see in regular customers? What's the impact that you're seeing?
So we have been able to help them repurpose half of their authorization department. We've increased their utilization by 7 to 10% for advanced modalities like MRI and CT. And that's huge. I mean, the overall available capacity is much higher, but that's what we've been able to achieve till today. And we're demonstrating that we can help them handle almost 24% of their phone calls with full automation.
So I want to be respectful of your time because we're running up to the top of the hour. Where can they go to find out more about you and your company and what you do?
We would love for them to reach out to me or go to our website, gogravity.ai, or they can reach out with an email to me. It's Shamit Patel at alphanodus.com, ShamitPatel at alphanodus.
Fantastic. And I can't thank you enough. Thank you for coming on and talking to one healthcare guy today, answering all of my AI 101 simple questions. So thank you for educating me, and I hope that everyone else hears and learned a little bit about not only a little bit about AI and AI in healthcare, but expanded their mind in terms of what problems AI can solve, because I think we have a very myopic view, but also hope that they reach out and are able to talk to you and see how you might be able to help them in their offices. So thank you for your time. I really appreciate it.
Oh, thank you for having me here. This was
awesome. Well, have a wonderful day, and I look forward to talking to you soon. We may have to do a
Thank
part two to this because I didn't finish everything.
you. Absolutely. Always
Thank,
happy to be here.
thanks so much,
Great
Shamit.
talking.
Have a great day. Bye.